crew vehicles comes up. Everybody's favorite experiment is this one, and it grows vegetables and plants. And so over the years, we've grown a number of different things, and now the crew gets to participate and eat those. And so these were chili peppers. So the crew is very excited about that one. We are the doctors on board also. So if any of you have learned to do CPR, you know, to start somebody's heart again, this is the way you do it without any gravity. You put your feet on the ceiling, and then you push down on the person by pushing your feet against the ceiling in order to do heart compressions. We take samples from ourselves of blood and urine and various other things so that people can understand what the long duration effect of being without gravity is on the human body. And then sometimes there are other experiments. She was sequencing DNA in orbit, the first person ever to do that. It's not all work. We have a big fabric screen, and they send up movies and sports, and so here she's watching American football. And then we do the spacewalks outside. We do maintenance outside, we change experiments outside. So now 2 people get into those spacesuits, again, that is protecting them against the vacuum of space. And you go outside, no longer connected by an umbilical, but always by a safety tether. So the backpack that they're wearing has all of the air that they need to breathe in it. And they can stay outside for about 9 hours. Because we knew people would be all over the outside of the space station, we built handrails into it, those gold handrails, so that you can actually maneuver yourself hand over hand and go all the way out to the end of the space station. Or we can put a platform at the end of the robot arm, and then someone can drive, a crew member inside can drive the person outside. Here's the crew member inside, driving that person outside by using cameras, so wherever they need to go, they can. If they come loose from the safety tether, or if they come loose from that robotic arm, that backpack allows them to fly back in order to grab onto something or to rescue one of their crew members. And so here she is using an Oculus system, training on board to use that flying backpack. And of course, everybody takes a selfie, so here's a spacewalking selfie. You can see the camera's wearing a spacesuit also. You can see the lens in the view there. The best module on board the space station is this one. It's got 7 windows in it, and it looks down at Earth, and it's a great place to watch the world go by. And as you do, this is what the world looks like as it goes by. We are not so far away that you can see the whole Earth. You have to be at the moon, 400,000 kilometers away. We're at 400 kilometers, so not very far. But this is the part of the Earth that you see. And there's some amazing things that when you look at it. This is a glacier in Alaska. This is a glacier in Argentina. These are mountains in Bolivia. This is the Namibian desert. These are the deserts of Australia. These are the waters of the Caribbean. Some parts of the US are recognizable, of course. This is Italy. But you look at it and you think, how calm and peaceful, and where are all the people? And then you see it at night. There are all the people. So I have a lot of night pictures in here, and in all of them you see that sort of fuzzy green glow across the top. That is the top of the atmosphere. All the air we breathe is below that line. That's the little thin eggshell that keeps us alive on this planet. And we are flying just slightly above that. So we're not that far into space. Okay, this ought to be recognizable to you. Right? There's the Strait of Gibraltar, and you can probably see down as far as Casablanca's probably under that bottom cloud, right there. Here's one you can see a little bit better, so you can see Tangier, Rabat, and all the way down the coast, and I think Marrakesh is probably down in the lower right-hand corner. Here it's easier at night. You can see it, so you can see Rabat and Casablanca, and Marrakesh is probably that farthest one on the right there. I didn't have close-ups of Marrakesh, but this is Casablanca. And here's Casablanca at night. And here's a picture I found of phosphate mines. Other parts of the world, here we are looking from left to right at Liverpool, Dublin, Liverpool, London, Brussels, and Paris. Dubai, recognizable to anybody. This would be Mount Everest. This is Tokyo, which I think is the brightest part of light. And then this one is Bangkok, and all those green lights you see are fishing boats. This is the Nile. And here, those triangles that you see in there, those are the pyramids. Now, every astronaut who has ever flown from any country has come back and said the same thing. As we go around the Earth, and you go around the Earth once in 90 minutes, you do not see the lines and the borders that separate the countries. You don't see that. You see Earth, and you see colors, and but you don't see the borders that separate the countries. Sadly, what you can see is the man-made borders. This is the man-made border between India and Pakistan. Here is the Korean peninsula during the day, and here it is at night. The bright light is Seoul, and in that dark spot, that little dot of light is Pyongyang. We see man-made borders. We see natural disasters. This is a picture of Los Angeles during the fires that we had this year, and that sort of wedge gap that's a little orange on the inside, those are the fires where all the electricity was out. Under that fog somewhere is Beijing. This is a hurricane. And those little flashes of light, that's what lightning looks like as we go across the Earth. Other phenomenon, this was what happens, this is what an eclipse looks like when you see it from space. So it simply makes a dark spot that goes over the Earth. I said we went around the Earth every 90 minutes, and so 16 times a day we see the sunrise and the sunset. And because we are flying at a high inclination, we see the northern and the southern lights. And this is a picture of a comet.
What's the name of this one? Do you remember?
I don't remember which one that is, no. Oh, Atlas. Atlas, yeah. And if you let your eyes adjust, then you can see all the way into the Milky Way. So this is what the space station looks like today. This is the crew that is actually on board space station today. The Chinese have a space station, and they are doing very well. They have a number of solar arrays on it. They've got a crew on it, and they've been exchanging crews. Now we're flying commercial vehicles in the United States, and so this is the SpaceX Dragon, and it's what we use to launch crew and cargo to space. And so there can be 2 of these Dragon capsules docked to the space station at any one time, one with crew and one with cargo. They come back and land under a parachute. They look a little burned when they come back, but those tiles are cleaned off and they're used again. Boeing recently flew a vehicle called Starliner. They flew a crew of 2. They flew it once successfully, docked it to the space station, and then they wouldn't let the crew come home in it again because it had some jet failures. But it actually is the one vehicle that lands on the land in the United States on airbags. The other commercial provider is Blue Origin, Jeff Bezos' company. He has a rocket called New Glenn, and one day it will carry cargo, but it has done 1 successful flight. Okay, this is the cartoon picture here. The next thing, when the space station is decommissioned in 2030, the plan is to have commercial space stations in the United States. And so this is what commercial space stations think they're going to look like. One is VAST, one is Starlabs north of Grumman, and the bottom one is Axiom, and none of them have actually put hardware in orbit yet. Where we plan to go next in the US and China, actually, is the moon. And here's what we've done so far on the moon since 1972. 1972 was the last time we had people on the moon. We have landed a few rovers. The top right, the top left one there is from India. The one on the right is from Japan. It fell over. And then the Chinese one landed successfully and then deployed a little rover. In fact, the Chinese actually landed on the dark side of the moon, picked up a piece, and sent it home. And they did that 4 years ago. So pay attention to China. In the United States, we've landed 2 little rovers on the moon. One landed and the battery died, and the other landed and fell over and the battery died. So we're not doing well. And these rovers are the size of this podium. I mean, they're not very big. The plan in the United States to send people back to the moon is in this big rocket called an SLS, Shuttle Launch or Space Launch System. We have flown it once with a capsule called Orion. We flew it with no people in it, but we did actually launch it around the moon. So there is a picture of the capsule with the Earth on one side and the moon on the other. And we successfully landed it back in the ocean, demonstrating that the vehicle is safe to fly. And that's how we will get crews around the moon. And next year, hopefully, we will fly an American crew around the moon like we did on Apollo 8, just around the moon, not to land. Because in order to land, we need something else. Right now, that happens to be a SpaceX vehicle, this giant starship. That top pointy part is the part that lands on the moon. Now, he's successfully flown that rocket after 10 unsuccessful flights. And he's gotten it off the ground, and he's actually brought back the bottom part and landed it. But he's got to get the top part landed. He's got to get it fueled, and he's got to get